A couple jump wires attached to an isolated 12 volt in, 5 volt out power supply. I have my lambda power supply there, so I can adjust the voltage, and just a multimeter. What I did here, what I'm actually looking to do is for my Arduino on my controller here, I'll probably use this Arduino for turning on and off the main contactors. What I'll do is I'll actually have it, I'll have it read the battery voltage once the first contactor turns on, and it'll know the actual battery voltage, and then it'll do a comparison to this, the output side, like the controller side of the other contactor, which has, for now, pre-charged resistors across it, but in the long term, I'm actually going to use a small IGBT on a heatsink so I can actually turn that IGBT on and pre-charge through the IGBT itself. But nonetheless, I'll use two of these. I'll use one hooked up to the actual battery side so that as soon as you turn on the first contactor, it'll read the battery voltage, and that'll give me an output. And what I'll do is I'll actually use a voltage divider to feed roughly 12 volts in at full charge kind of thing, and then the output will be a 0 to 5 volt signal, which will go to the Arduino, and the Arduino will be able to read that and say, okay, well, this is where the battery voltage is. And then the other side of it will be the pre-charge side, like the cap side, and as the voltage comes up, it'll say, okay, well, now it's within 90%, we'll say, or something like that, like within X amount of volts or X amount of percentage of the actual battery, and then it can turn the second contactor on. That way you don't get arcing on the contactor and fry your contacts inside on the contactor, which actually quite commonly causes them to stay welded on, which is a dangerous thing. This seems like it should work really good. So turning on the power supply, so I have 10 volts there, and I got 5.19. Now if you look, it's really using, like, basically, try and let my phone zoom in there, it's basically using next to no current. Now I'm sure once you put a bit of a load on it, that voltage, blah, 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 it might, you know, once you put a tiny little bit of a load on it, it might change the actual output. But I can work with that. I can make a voltage divider do something like 0 to 9 point, whatever, like maybe that's 9.9 or something. We'll get it down to where it reads, like, so you bring it up somewhere around there, you know, just fine tune it a bit. So 5 right on the money, because you don't really want to feed more than 5 volts in on the analog input on the Arduino. And then I'll let my camera zoom again here, or focus again here. That's just below 10 volts, which is fine. I can make a voltage divider. I can also buy different isolated power supplies that take a higher voltage input. I looked, and there isn't really anything to take the full 470 volts, but either way, I can make something work. And with that low of a current draw, a guy can use really high resistors in his voltage divider, so it doesn't have to, because it doesn't have to flow much current. So I'm gonna experiment with this a bit, but I have a feeling like, so I can turn this knob way down to like next to nothing, excuse me, and it'll still produce an output voltage, like coming down, come down, come down. And like it'll even produce a 0.1 volt there, or 0.12. Like I can turn that down further. You know, you can get it down to like nothing. And let's see what the lowest it'll go. So, you know, like 0.06, and like it's not even registering. So I can just turn the fine tune dial up a bit here. And as I turn that up, it climbs slowly. It's a linear scale, essentially, is what I'm trying to say. So, and you can slowly turn it up, and as you're turning it up, so what I'm pointing out here is we can use this as an analog signal voltage input output for an isolated voltage, you know, like a voltage signal isolator, essentially. So basically the battery side will have a voltage divider, but I never want to connect anything from the battery to the Arduino, which is also sharing a ground with the main controller brain. And none of that stuff should never be connected to any part of the battery, even if it's through a voltage divider or resistors or anything, because that's potential for, first off, electronics failures, second off, somebody to get hurt, because you might be tying in, say, a computer cable that hooks up to the Arduino or whatever, and you'll go to program it, and now your computer's connected to possibly the negative side of the traction pack, and then you go to touch the body, or maybe you have to grab a wire for some reason on the positive side. You know, like, you have to think of all these random scenarios, and at the end of the day, like, maybe a contactor weld's shut and you don't know about it. So a guy has to consider all this. Now down the road, if this proves to be a reasonably reliable signal, it doesn't have to be 100% perfect, but I would say, you know, maybe within a couple percent or something, if it's close enough, I can actually use the Arduino to display a gauge on the dash of my actual battery voltage, and I can have the Arduino produce, I think I can have the Arduino produce my 0 to 5 volt signal to send that back to the controller brain, so the controller itself will actually know the battery voltage. And right now I don't believe that's a big deal, but if we, down the road, we're actually looking at having the controller produce all its data for, Lebowski's working on something kind of cool for having gauges that'll read the information from the actual brain and display it on the dash. So nonetheless, just turn that up slowly. Like, I can actually probably move this here. Wire stayed on there. It's a little tricky without getting my arm cuff caught on my jumper connections. So yeah, you can turn the voltage down and turn it back up, and basically that gives me a usable range. That's all I'm really concerned about, as long as I have a usable range there. So what I'll do is I'll actually probably take the output of this isolated supply and hook it to the analog input of the Arduino, and then do another test on the voltage, like reading it real time, and see what it is. We'll call that under load. It's not necessarily under load, but we'll call that under load. And obviously I should have caps across this, but the caps don't really put a load. They just kind of, apparently they make the isolated supply work better. I think it's to do with the way that it can reduces its, the way it, what the hell is the word I'm looking for? Nonetheless, it's to do with helping make the isolated supply work better. But at the end of the day, it's a good thing to have caps on each side either way, so that it buffers the signal if there's any sort of noise on the lines and whatnot as well. So this looks like it's pretty promising.